everyone, we're going to do a lesson about symmetry today. Have any of you guys heard about what symmetry is or learned anything about it? I'm going to give the students a chance to respond. Most likely the only kind of symmetry that they've learned is reflection symmetry in which, or the paper folding symmetry in which they can fold a figure across the line of symmetry and see the same thing on both sides. Next I'm going to just give them a chance to look at some pictures if they don't respond to anything about past experience with symmetry. So we're going to look at some pictures. The first is a snowflake. Next, the beautiful butterfly. And next is the Texas Capitol building. Here's a famous piece of artwork. And finally we have a cathedral that's in Rome. Now, do any of you guys see any similarities between any of these pictures? And once again, I'm going to give the students a chance to respond. Symmetry is very important in our world today. It's used in nature. We can find it a lot in different bugs or the butterfly that we have here. It's also used in a snowflake, and while every snowflake is the same, most of them have a line of symmetry, which we call rotational symmetry, which we'll talk about and illustrate later by making our own snowflake. And finally, symmetry is used widely in different architectural buildings, as we see in our nation's capital and in the different cathedrals. And the reason symmetry is used in that, and also the various art forms that we see here, is that symmetry just makes things more attractive. It's been proven that anything that's symmetrical is more attractive than things that are asymmetrical or not symmetrical. So anyways, the first thing that I want to talk about is what congruence is. And I know that we've talked a little bit about this in terms of triangles. Do any of you guys remember what congruence means? Now, once again, give the students a chance to respond. And congruence is pretty much a relationship between two figures that are the same size and the same shape. And symmetry, on the other hand, is used when a single figure is divided into parts, and each of those various parts are different, the same size and the same shape, and they also have a particular direction. So, again, I'm going to ask the students if they have any questions, and if not, we're going to move on to the first type of symmetry we're going to talk about today. The first is called line symmetry, or reflectional symmetry, and this is probably one of the two types of symmetry that students are going to be most familiar with. So I'm going to begin by talking about this. Okay, first we have, I'm going to ask students what line symmetry is, and we're going to talk a little bit about what the name means, if they can give any hints that come along with the name line. So, and to illustrate this, everybody is going to have a piece of paper in front of them, a rectangular sheet of just regular computer paper, and I'm going to ask them just to look at it and examine it, and then I'm going to explain what line symmetry is. And line symmetry, a plane can only be classified as having line symmetry if and only if it can be folded across a particular, it can be reflected across a line so that the figure is the exact image on the other side. And this means that the new image that you make has to be the same as the one in the beginning. So, and the line of reflection is also known as the line of symmetry, hence the name line symmetry. So, and each point in the figure is the exact same distance from the corresponding figure on the other line of symmetry. So, if you're doing this with graph paper, that would really help so that the students can see exactly what they're the line of symmetry that they're reflecting across. So to illustrate this, I'm going to ask students to just imagine that the line of symmetry is the solid black line that I've already previously drawn on this paper, and I'm going to ask them to just fold it across this line to see if this particular plane figure, or rectangle, has a line of symmetry. So we're going to fold it across the line, and we're going to look and see if the ends match up, and clearly they do not. So is it safe to say that this figure always has line symmetry in terms of this line?
No.
No, it doesn't. Very good. So, and you can look at different plane figures. If a lot of the time I would also look at a square, and a square has lots of different lines of symmetry. And I would illustrate this by doing paper folding method. So next we have what we call rotational symmetry, and a plane figure has rotational symmetry if and only if it can be rotated more than 0 degrees and less than 360 degrees, and at any various point that you rotate it with, it coincides with the original image. So sometimes I have a hard time remembering where the degrees are in terms of rotation when I'm trying to rotate a figure and determine how it's rotational, the different rotational symmetries it has. So I made a clock. It's called my rotational clock. And we are going, many shapes have different kinds of rotational symmetries. So first of all, we're going to make a snowflake. We talked earlier about objects in nature having different kinds of rotational symmetry. So we're going to look at a snowflake. And we're going to make this by using regular coffee filters. So my snowflake, we're just going to fold it first. So I'm going to fold mine, I'll fold mine into 4. And if you're hungry, you can also do this by using a tortilla. So after I folded my snowflake, I am going to just make some designs and make it my own little snowflake. So I give the students time to do this on their own. And each snowflake is going to be different, and it's going to have different rotational symmetry. So I would also spend some time examining them and allowing the students to make their own clock so that they can also find the rotational symmetries on their own. Alright, so I think I'm done with my snowflake. So my snowflake looks kind of like this. So let's see, where would we start in terms of knowing where to rotate my snowflake, and give the students a chance to respond. So let's see. We're going to start it off at 0 degrees. I noticed that my snowflake has 4 major points. So I'm just going to line up one of the points up with 0 degrees. And as any man-made creation, it's not completely perfectly symmetrical, but we're just going to factor in that human error. So we're going to start it off at 0 degrees here. And remember, rotational symmetry is any degree that you rotated it within this within a full rotation of 360 degrees. The image must correspond with the original image. The rotated image must correspond with the original image. And so I've already made, I went ahead and made the original